All right, we're on. Welcome everybody to again math class. This should be Monday, March 23rd. Just a couple of new updates. I updated my sound. I actually looked into my old recording stuff I did. I did a lot of videography back in college, a lot of different videos I've made and little projects I've done. And I was able to whip that together. And yeah, my sound's a little better, so I don't have that webcam echo anymore. Also got a haircut. Feel like it was being a little bit shaggy. I tried looking like a bum during this virus slash whatever's going on with the world, and I felt like I needed to switch things up, right? I don't like looking like a bum too long. Okay, but other than that, let's get to the lesson. Couple of things for announcements. Please don't forget to comment in the discussion. You will not get credit for this lesson unless you do. Another thing is we'll have a learning activity after this. This will be continuation on for tomorrow's lesson. There is a PC on Thursday. Still trying to figure out how to do it. I'm thinking right now maybe to do some conference on Canvas and just have times for each period. And if you miss those times, then you just go on to the next time. But yeah, I'll have to figure it out. Talk to Miss Yates about it. Also, there'll be a review posted during my streams tying to that. I'll have one Tuesday and Wednesday for you all. We can go over this review that I put up for the PC so that you don't have to freak out and you have that support from me, okay? Also, retakes, you'll have to sign up for that. The end of the quarter is this week. So I'll post that as well on modules in Canvas, and you just have to sign up for a date. I've done this last week, and it turned out to be pretty smooth. No problems there, and I think a lot of people were able to get stuff done. So I felt pretty good about it, and I think I'll keep doing that again, okay? Other than that, let's get into the lesson. So now we got to do now just a good warm-up to get us started. Okay, number one is to find an equation of a line that goes through the point negative 12, 80 and is perpendicular to y equals negative 2x minus 74. Okay, so looking at this, remember a perpendicular line to this particular line of y equals negative 2x minus 74. Perpendicular means you have two things. You have, in this case, the slope is negative 2. To make something perpendicular, you need two things, which is the opposite sign of that, which is positive 2. If this is negative 2 over 1, I can also take the reciprocal, which is 1 over 2, okay? So don't forget to put in your point slope form. That's y minus y1's 80. And that's equal to 1/2 of x minus negative 12, okay? Again, you should be able to simplify this pretty smoothly. Looks like I get 1/2 x plus half of 12 is 6. Add 80 to both sides. Okay, so your answer should be y equals 1/2 x plus 86, okay? All right, next one is the line that's parallel to the point 2, point negative 13. That's where the line's going through. Parallel means the same slope. If you look at this slope, well, y equals mx plus b, there's nothing in front of the x, so therefore we can assume our slope is 1, okay? Parallel means the same slope, so I'm just going to go ahead and get started with this, okay? So I have y minus my y1, and that's equal to my slope, which is 1, x minus 2. I'll simplify this as x plus 13 equals x minus 2. Subtract both sides. Feeling good so far? Your your y is equal to x minus 15. Okay, that's that one. That was pretty smooth, right? Next one is the distance between the two given points. Remember, we need the distance formula here, okay? So with distance formula, that's your x1, that's your y1, x2, y2. To find my distance between that, I'm going to need my calculator. But what that is just going to be your difference between your y's and your x's, okay? So we can start with our x's, 10 minus 4. Remember to square it, plus y2, which is 15, minus negative 7 squared. That should give me, simplifying this together, we get 6 squared plus 15 plus 7, right? Minus makes a plus. That's 22 squared, I think. Yeah, 22 squared. Okay, I'm going to put that in my trusty calculadora. Plus 22 squared. So this is equal to the square root of 520. There you go. Square root of 520 is 2 square root of 130, or I can just say 22.803 or 22.80, okay? So that is going to be my answer to that one. All right, we can just go ahead and circle those or put a square around it. Okay, that's the warm-up. So today's lesson, we're going to learn about perimeter of polygons and area of triangles and rectangles. Nope, that is not it, actually. It should be area, perimeter, and circumference. I need to fix that. My bad. But today you're basically using geometric theorems and continuing trying to find, I think, particularly the area, okay? So just a couple of things to go over again. Remember what a quadrilateral is? A quadrilateral is just something that has 4 sides, an enclosed figure with 4 sides. The sides also need to be straight, okay? So it needs to be 4 straight sides. So if you look on the left here, I see that I have all those different types of quadrilaterals. On the right, notice how we have 3 different non-examples of that, right? If you can see here, the first one has a gap. So no, we can't have gaps on our quadrilaterals, okay? Notice here, this has an intersection. We can't have an intersection as well, okay? And then notice on the third one, what do you notice about that? If you see, it does kind of have 4 connecting sides, but you also have a round side here, okay? You can't have roundness in a quadrilateral. Again, quadrilaterals have 4 straight sides, okay? So again, quadrilateral is an umbrella term. We call it umbrella term, meaning that with all this stuff encompassing us, we have quadrilaterals, right? But then breaking it down, you have different types, right? Just kind of like you have the human race, and then you got people from different countries and different races and all the other stuff, right? This is the same idea. With quadrilaterals, you can see it's broken down to 3 main groups: your kites, your parallelograms, and your trapezoids. And then those break down into their own. Looks like with parallelograms, you have rectangles and rhombuses, which turn to a square when you try to figure those out, right? What's really cool, I know this is a lot to process, but I think it's pretty interesting. Again, this is the family of quadrilaterals. If you look at the very, very, very outer of everything, it says simple quadrilaterals, right? That's the general umbrella term of it. Within those, you have 2 different types. You have your concave quadrilaterals. Okay, notice that in the gray area, those are the ones that look like they're caving in. Those are concave. And then you have convex quadrilaterals, and those are kind of the more wider ones shooting out and stuff, right? And then you have everything inside of those. Man, if you're looking at this, there's a lot of interesting words. In the UK, instead of a trapezoid, they call it trapeziums. That's interesting. And if you look at above rectangle, what's that? OBBNG? Obung? I don't know what that is. Basically, in my eyes, it looks like a half a square. I don't know, but half a square is just a rectangle, isn't it? That's silly. But, these are just the terms that we use and all the families related to quadrilaterals, okay? So go ahead and write these down. You'll need these for today's lesson with the examples we have here: the rectangle, the square, and the parallelogram, and they're encompassing perimeters and areas. Notice how, again, perimeter is just the distance around the figures, right? So if we just know the distance around it, we can just add it all up. We don't need to memorize a formula there. But area, just in case for you, we have that for those 3 figures. And for our new figures, for our trapezoids, and it looks like triangles as well, we got our areas with those. A little bit different, but looking here, it looks like the rhombus and the kite actually have the same area. So that's pretty interesting, right? Looks like the only difference between those 2 is that the distance inside looks like D1, D2. Those look the same or similar to each other, and the kite D1, D2 is a little bit different, right? D2 looks longer. And then your trapezoids is just going to be your 1/2 H times your 2 bases added together, because a trapezoid makes 2 different bases, okay? But yeah, it looks pretty good. All right, let's get some practice in. So looking at the given shape, again, this is just getting our brains thinking. Number 3 looks like the harder one, but we're trying to find area, okay? So if, number 1, I'm trying to find the area of this kite. Well, I know that from the formula, it's just A equals 1/2 times your D1 times your D2. And those are the distances within the kite. In this case, our area is going to be 1/2 times 7 times 16, right? I need a calculator for this. I'm not a super genius that can just compute this right away, right? So let me throw this in there. And it looks like our area is 56, okay? I could say it's 56 square inches or inches squared. That would be the more precise and exact answer for that. All right, looking at number 2, that is a trapezoid or a trapezium, right? That one was your A equals 1/2 times h times your base 1 plus base 2. So you have your top and bottom added together times by the height. Height is given, so I can just write that all out. 1/2 times 3.5 times 7 plus 13. Okay, well that just turns into 1/2 times 3.5 multiplied to 20, right? Let's throw out my calculator. We got 1/2 times 3.5 times 20. That should give me 35. And it's not just 35, but it's 35 meters squared or squared meters, okay? Now here's the hard one, number 3, isn't it? If you look at this, you got what? 3 different shapes. You got one big old parallelogram. It looks like trying to see if you also looks like we have a triangle. You can look at this as maybe a trapezoid with a triangle and a little square. But just looking at it, what I care about, this generally is a parallelogram, and I should just be focusing on the equation for the area of a parallelogram, right? Again, the area of a parallelogram is 1/2 base times height. I think I want to double check that just so I have it written down that bottom. No, parallelogram is just base times height, okay? So again, my parallelogram, the area is equal to base times height. And it looks like I'm given that, okay? Again, this is about the shaded region. Notice about the square. There is a white space in that square. So what do you think we got to do? Think about it, right? I'll give you a moment to think. If you look at it, you can see that, well, I want the shaded area, and I know the whole shaded area is going to be base times height of that parallelogram, right? Well, if I'm trying to take that away, I just need to subtract the area of that smaller square, okay? So really the area here could be, let's just write it out as A is equal to your base, which is 42, times your height, okay, minus the area of that little square, which I know is just going to be 6 squared. All right. Go ahead and process this, and we're going to break it down. We got 42 times 12, which is 504. Whoops. My screen's going crazy. I apologize. That's 504. Let's see. Oh, it's because of my stylus. Again, you should be processing this. Let me fix my stylus, just like normally what I do in class. Usually the stylus dies out on me, right? In the middle of the most crucial times. But again, by now you should be throwing in those calculations and seeing that 504 minus 36 is going to give you 468, okay? All right, let me pause this video. I got to double check on something with this. All right, we're back. Looks like my stylus was dead on battery, but if I was to simplify this, it's 468, okay? Man, it even looks like it got more beefier. No? Okay, that should be your answer. Let's go on to the next examples. Okay, so looking at this, now I gave you a graph. You should be able to use this graph with that. Looks like 4 different lines, that quadrilateral with those 4 points, and find the area of that. This should be a fairly easy example. I mean, I can see clearly that is a that clearly is a trapezoid. And with the trapezoid, I need to know the bases. I can count those bases, 1, 2, 3, 4, 5, because that's straight vertical, right? In the left side, I have 1, 2, and 3. Okay, because I have that, that makes it a little bit easier. If I was to eyeball this with the height as well, we can see that the height is 2, okay? So I know that, let's say B1 is equal to 3, B2, that's equal to 5, And then my height is going to be 2, okay? Looks like this is supposed to be an easier example. So if I was to put this into the equation, 1/2 times 2, parentheses 3 plus 5. We can simplify this as 1/2 times 2 is 1, 3 plus 5 is 8. My answer is 8, okay? So this is just getting you warmed up with the idea of using these graphs. I know that the previous learning activity kind of had this as well, but we'll just keep practicing it, right, and getting that in. You can always go back and answer those questions after this lesson too, right? Or send me an email, come to my stream. I am more than welcome to help you with that. Okay, looking at this one is a parallelogram. Remember parallelograms, we need to have your base and you need to have your height. Okay, looking at the base, that's fairly easy. I can see that's 1, 2, 3, 4, 5, 6, 7. And then my height, that has to go to one of those corner points, right? All the way down to the base. So that's 1, 2, 3, 4. Okay, I can see that's 4. I'm just trying to see if there's anything else that I want you to understand about this. When I was preparing this lesson, I think that was as straightforward as it comes. Obviously, this will get a little bit harder, but we're just practicing reading the graph and connecting those equations to it, right? So then the area is going to equal your base, 7 times your height, 4. That should give you 28, right? And there's no units of measure here, so I don't need to worry about that for now, okay? All right, now we're getting a little bit harder, right? Now we're trying to figure out some other things with it. Again, remember I gave you all those different equations of area. Looking at this one, I can see we can form maybe just 1, 2, 3, 4 different shapes. There's a lot of different ways to do this, right? I think that's what I like about geometry as well. When it comes to this in geometry, you can see like many different patterns to it, right? It's just your way of just clunking in different shapes into it all. And this is exactly what we're going to do, okay? So while I was just talking, I was also thinking through this. I can see that I can create 4 different shapes. Excuse my rough drawing with it, but you have that creates a triangle and a rectangle with it. Technically, I'm trying to think if I could put a quadrilateral or a trapezoid with it, but I'll just be safe and stick with what I know on the top of my head, right? And I can also do this. There's just so many different ways to do this, right? Because I'm already seeing like, oh, you can make that small little square and then do that. But again, it doesn't matter necessarily. You'll definitely get the same thing. Remember, area is the units inside the shape. And yeah, let's just get to it, okay? So if I was to get this, I can clearly see with this first one, this is a height of 3, and the base is 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and then here it's going to be 3 again, except it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This has a height of 3, base of 1, 2, 3, 4, 5, 6, 7, 8. Okay, again, I understand there's probably a lot of different ways to do this. I'm just doing the one that's on top of my head. And this one has a base of 3 and height of 1, 2, 3, 4, 5. Okay, so I got a lot going on here, right? I have 4 different shapes, and I'm just going to add up all those areas, all right? So the area of the first one, that's going to be your 3 times 13 plus base times height is 10 times 3. And again, I'll do that last rectangle before I do a triangle. Base times height. And then plus your 1/2, 3 times 5, okay? 3 times 5. Let's simplify that up. We get 39 plus 30 plus 24. And then 3 times 5 is 15. Half of 15 is 7.5, right? I could throw it in the calculator, but I'm feeling very arrogant right now. You get 60, 80, 93. Yeah, 93 plus 7.5. That's going to be 100.5, right? That's 100.5 is your area. Again, if I was to count all those little squares, I'd get about 100.5, 101 half. All right, we'll just keep on getting this momentum going, right? All right, looking at this one, I'm going to do the same thing here. A little bit more complicated though, isn't it? If I was to find the area of this given shape, I noticed that it is in meters, so we'll include that. I'm already thinking at the top of my head that I can create a rectangle and a triangle of this. Okay, can you see that right now? This should be a fairly easy example. I think what's missing here, I'm going to put a question mark to it, is going to be this one, and this one, okay? Those three different things is what I need to be able to find the area of this. Besides that, I know that the area of that rectangle is a 10.7 by 15.2, but everything else is a little bit questionable, right? So with this part, again, I can see this is this way. I see that this top here matches with that, and then this side here is going to match with this much, right? It's kind of interesting too, because I don't think it's up to scale with really what it is, but that 2 meters should be a little bit smaller in my opinion, right? But if you notice, what I can do is I can take that longer length and subtract the one that I do know, right? So if I can take 15.2 and subtract with that smaller part of 2, then I'll find that missing piece. Okay, that's what I want to do. If I do 15.2 subtracting 2, well, that remaining piece right here, right? That remaining piece, I know that's going to be 15.2 minus 2, which is 13.2, correct? Yes. So I know that is going to be 13.2. Because if I add 13.2 with 2, that's going to give me that other side of that rectangle, right? And then looking at the bottom of that, well, because it's a rectangle, this bottom part is going to be the same as that top. So that's obviously going to be 10.7. So then how would I get that other piece? I'll keep doing green of that base of that triangle. Well, if I know that part's 2, that's 13.2. So looking at this, right, I know that's 10.7 with that rectangle. Now I can find the remainder of that by taking that 23.5 and subtracting 10.7, right? Too many decimals. By the way, I'm doing this late at night too, so my brain's not working. But if I do this on my calculator, I get 12.8. So I know that rectangle or that triangle is 12.8, right? Okay, well, easy enough is I just need to find the area. My area is going to equal the base of that rectangle. Let's just say it's 10.7 times your height, 15.2. Let me make this more clear. 15.2 plus the area of that triangle. And I know that triangle is going to be 1/2 times your base, 12.8, times your height, 13.2. Right, times those all together. Let's all put this in a calculator. 10.7 times 15.2 is 162.64 plus, let's see, half of 12.8 times 13.2. That's 84.48. I add those all up. I get 247.12. And remember, this is area, so it's meters squared, okay? Square meters. Man, crazy, right? So, yep, just looking at that, you need to be able to cut that up and be able to add those areas up. And yeah, I would say this would be a typical ACT, SAT question as well. I've seen this a lot. And think of it as like a puzzle, just putting things together, right? So this one says, find the area of the trapezoid. Okay, round your answer to the nearest tenths place. First thing I need to understand is the area of a trapezoid. So the area of a trapezoid, I want to say it's 1/2 base times height times the b1 plus b2, but let's double check. Yep, 1/2 times h, b1, b2. So I know the area of a trapezoid is 1/2 times h times b1 plus b2. Well, it looks like B1 is this, B2 is that. But I need to find my height. This is what we're gonna do. I want you to pause the video and then try this yourself, okay? Pause the video, try this yourself. I'm gonna figure this out along after you pause and we'll get together. Okay, hopefully you paused. I see from here that I can create a rectangle and another triangle, okay? But because I have those 2 points, yeah, it looks like it's gonna be a couple puzzle building. But I can see that I can just take the area of those 2 things and add them together. But let's just humor it and say we'll try to find the area of a trapezoid, okay? So we got to find that height. Let's just do it so that we can kind of get that practice in, right? So I know in red those 2 are the same. So then what I need to do is take 35.8 and subtract 20.2 from that, right? So I do that. I know that it's going to be 35.8 minus 20.2. That's going to be 15.6, okay? Well, notice how I drew that straight line down. That creates a right triangle. With that right triangle, I can use the Pythagorean theorem, right? This is going to be your A. Or let's call it H for height, right? So let's put that in. I know it's going to be H squared plus 15.6 squared. And that's equal to that hypotenuse, which is 22.4 squared. Okay, simplify that out. That's 243.36, and that's equal to 501.76. Okay, we'll subtract those out first. All right, 243.36. I get H squared is equal to 258.4. Square root that bad boy. H is going to equal 16.074. You know what? I'm going to keep H as that square root. Let's just keep it as square root of 258.4, just so I can have a more precise answer in the end, right? So now I can take my area of that trapezoid. So we can say area equals 1/2 times your height times B1 plus B2. I can take that area now of the trapezoid and multiply it by what I found. Again, you could easily do the rectangle and triangle thing. I'm just showing you another way of doing this, right? Either way works perfectly fine, in my opinion. 35.8. Okay, let's just throw this all in a calculator. So I got 1/2 times square root of 258.4 times parentheses 20.2 plus 35.8. That gives me a total of 450.095 or 10, okay? That's also in inches squared. And there you have it. Okay, that's a lot to process, I understand, right? But you can totally do this. It's just kind of cutting pieces up together. You could add those up, or you can use the area of a trapezoid. This one asks for the area of a trapezoid, so I highly recommend that you stick with the program with that, right? Again, these are your ACT, SAT problems that you'll see in the future, again, just to help you out. And it's also a good way to build that brain, right? That's why we do math, just to build that brain. And also make a lot of money if you know how to use it. Hone that power. Okay, so looking at this, it says do now. Yeah, this is for tomorrow's lesson. So yeah, I think we're done, class. That's going to be most of our lesson now. What we did was, looking at it again, we were able to use the coordinates to prove geometric theorems. We found the area of all those different shapes and put it together and find a good area with the unit, right? Okay. Last thing, just a reminder for you all is that you need to comment in the discussion be part of the conversation, say something good. I've been reading them very fast. Some of you guys been, or some of y'all have been saying it very cleverly in those little comments there. And I really appreciate that. It keeps things alive, right? Makes it fun. Everybody else, you're just saying one or two liners. That's okay too, but please process these videos and type what you're thinking with it. Again, it just helps you with learning. And I'm doing this all on purpose for you. Okay, another thing is work on the learning activity when you can. There is a review up for the PC. We'll have that on Thursday. I'll put out some information how I want to do the PC. I'm leaning towards Windows where you just come in, take it, but who knows? I'm going to check with Miss Yates, see how she's doing that with her Honors 2 kids with the higher level math, right? Retakes, the end of the quarter is this Thursday. You can still retake with me. I feel like most of you all are pretty much satisfied with what you have for your grade for third quarter. But you can always still work with me, right? You can email me, message me. People are finding me through GChat, so if you find me there, that's fine too. And also, please come to my stream. We're having some good relaxation music. It's good to check in with each other, right? To see how we're all doing, especially the ones we don't see. And we could do some math together and maybe watch some goofy videos. Maybe play some Tostino pizza roll videos. Yeah, I remember that. Do you remember? Okay, bye. Oh, I'm still recording. That's awkward.